Alright, so our plan today and tomorrow, I guess the rest of the week, is today we're going to do these notes on combining two variables. And then we're going to do a worksheet that y'all are going to turn in. And then on Wednesday, tomorrow we're going to do a free response packet that's going to be our third major grade. Let you work on it in class here. And then hopefully you get it done tomorrow. And Friday we'll just be doing nothing. So if you get your work done tomorrow and like you have nothing to do here on Friday, then I'm fine if you just don't show up. It's okay. It won't hurt my feelings too much. I mean, just a little. But all right, so that's what we're gonna do. We're gonna do this. We're gonna do a worksheet that I'm gonna pass out, and that's our plan. All right.
Start writing in Chinese.
Sweet.
Chinese numbers.
Okay, so on this first one, we've got Pete does Jeep tours, does some half-day trips in a tourist area, and there must be at least 2 passengers for a trip to run, and he can hold 6. Here's the number and the proportions that go with each. So there's the proportion. All right. Can you compute the mean or expected value? So it can be written like this: the mean value of x or the expected value of x. So can we get that, and can we compute the standard deviation? So we did notes on Friday on how to do this on your calculator. So you go to your calculator and you have to create a new document. So not the scratch pad, you go to new document, you make a list and spreadsheet. So make sure to name your list. So maybe I'll pull mine up. All right, let's see. So, new document, list. All right, make sure to name your list, like give it like X, and you could name the other one P of X or probability or Y or whatever you want. So maybe this one says PX, so maybe I'll just do it like that. Oh, it didn't like me putting parentheses X, so maybe I'll just do prob. Alright, let's see. 2 enter, 3 enter, 4 enter, 5 enter, 6 enter. What was it? 0.15, 0.25. 0.05. Alright. So then you created a new page, you added a calculator, then you've got menu, statistics, calculation, one variable, click OK, and then on the X list you have X, and then on the frequency list, on yours, you have to scroll like all the way down and click whatever you named the probabilities list. So So then it should look like this, like X and probability, which can't even see that on the board there. Click OK. Let's see. I got mean X bar of 3.75, standard deviation 1.08972. So the mean is 3.75, and I guess we're talking about passengers. So if we just observe Pete's Jeep tours and we just did a random sample, we did many random samples, we would expect that there would be about 3.75 on average. And then do like a standard deviation of 1.09. So standard deviation is just saying, like it's not exactly 3.75, there's like a variant, it varies about one passenger, a little over one passenger, plus and minus. That's like a typical range from, so what would that be? Like 3.6 to about 4.8 is our typical range. We can have stuff outside of one standard deviation, but that's like a typical range of values that fall. Alright, so mean,
How did,
what's up?
so when mine comes up, like,
Wait, trying to do the
trying to,
monthly,
yeah,
like to the page or control page.
Control zone.
So it's just a weird act.
Control.
Act over there.
okay, but then does it?
Menu.
Stuff.
Statistics.
Oh, okay. Yeah, okay. I just did that wrong, because I was doing it from the column, and I was like, wait, that doesn't work.
Alright, okay, so, on number 2, Pete charges $150 a passenger. Let the event C be the total amount of money that Pete collects on a selected trip. What's the mean and standard deviation? So how much money do we expect Pete to get, and what's like his standard deviation? Well, I guess it's not X anymore, it's C. So what's the expected amount of C? What's the standard deviation of C? And C is the amount of money he gets. So $150 a passenger, and we expect over many trials to get 3.75 people. So 3.75 times $150 is 562.50. There we go. Okay, so expect that much money as an average. And then let's think about like our standard deviation. So if I had like my fingertips was my spread, does my spread get bigger when I multiply out? Like when I get the values and I multiply them? Yes, they like get bigger. The spread gets bigger when you multiply. So I need to multiply my standard deviation by $150 as well. So my varying prices, I got, yeah, could vary by $163.50. So we expect around 560, but it could be anywhere from $400 to $725. Like it could be anything in that range. Would be a typical amount. So that's what we expect, but this is the plus and minus, like standard deviation from the mean. We expect typical values somewhere plus or minus in there. Alright. But it costs Pete $100 to buy permits, gas, ferry pass for each trip. So what is his total profit? So determine the mean and standard deviation. So the expected amount. So what we're doing is we have to subtract, we have to take away 100. On this one we were multiplying because it's per passenger was multiplying. On this one though, it's just a flat rate for however amount of trips minus 100. So the expected amount of profit, and V is profit. So the expected amount of event V is, alright, so $562.50 is our mean, and we know we have to take away $100 every time, so I'm just going to do minus 100, $462.50. Alright, standard deviation though is a little different because standard deviation is like your spread from the mean. And in this case, like if I was to draw this, like here's this information down here, like $562, and I typically vary whatever, $163.50. So just because I had to subtract and now my mean is at 462, does that change like, does the actual distance of my spread change?
No.
Like, the spread just moves in like a block.
Yeah.
Like the actual spread. So like this still spread number is still $163. So standard deviation is actually still the same at $163.50. So the mean changed, but the spread from that number, it didn't change. It's still the same amount from there. It didn't. This only changes. So standard deviation, it changes. Only changes with like multiplying and dividing. Like if you plus or minus to your values, it just moves in a block with the mean. The spread doesn't get bigger or smaller. It's only if you get divided or multiplied that the spread gets bigger or smaller. So this thing changed, but standard deviation the same. On these, both of them got multiplied. So there's those answers. Okay, so an important point that we need to know is that so the spreads only are affected by multiplying and dividing. Otherwise, sticking out the same. Alright, let's do another one. Pete's sister Erin lives in a different tourist area. She wants to do what Pete does. So she does her own business with a smaller vehicle. And so here's her values. Like she can have 2, 3, 4, 5 passengers, and here's her probabilities of each of those passengers. And we're asking, what's the expected amount of event Y, which is Aaron's passengers, and what's the standard deviation of event Y? So do that on the calculator. Try that one out. What's the average amount of passengers and our standard deviation? Huh?
And the tested positive, so we're probably off. Yeah.
No,
No, me and Olivia. So, I'm still here.
So,
So we're probably gonna get a phone call pretty soon.
Someone's about to
Leave.
come up and drop you. No.
You said all of us. And I
well,
said,
until
Is it because y'all are in the
TOK class?
No, we have lunch.
It's if they go by lunch. Like who you have around.
Well.
maybe I need to leave too.
Yeah, Mr. Hamilton needs one.
Yeah. Lunch in my room.
I should have came at
I
lunch
think
with
I'm never
y'all,
here at
like,
lunch
yesterday, so I could go
anymore.
home.
Well,
Hopefully, if you
now
go,
I gotta
in-
go.
if you go in this class for you, you can do TOK.
Yeah, well, what am I supposed to do? Cause I have to present online.
And if you can't do it from home.
Yeah.
Just sit in your car, turn on the hotspot.
I don't have
say
one.
just go anyway. Like, sorry.
I'd say y'all just
drive
need to go to
by.
class until they
Yeah.
tell you to
Yeah.
leave.
How long ago were you like living?
Thursday, Friday.
Mm.
Alright, did someone get our mean and standard deviation on the calculator?
Oh wait. The mean is like the weird key thing, right?
It's the one that looks like this, X bar, and then standard deviation is that symbol.
Okay.
The E one is not the mean. You're talking about this symbol, aren't you?
Yeah.
Yeah, not that one. Not that one. Alright, if I did it right the other day, I think it was 3.1 passengers
Mm-hmm.
and like a 0.94 standard deviation.
Yep.
Yeah. So she's got a little bit less passengers than her brother, but a little bit tighter, smaller of a standard deviation of a spread. So there's that. Alright, Now we're gonna practice combining. So on the back side, number 5, we're gonna use Pete and Aaron together. So they're brothers and sisters, so maybe they're gonna like combine their stuff together to see what they've got. So how many total passengers, which is event T, is what they're labeling it. So they give you like a letter. Can Pete and Aaron expect to have on their tours on a random day? So what can we expect the total amount between those two in passengers? So for the means, it's pretty simple, like just like how we always multiply, always subtract, add, whatever. Like on the means, I think Pete was like 3.75 plus Aaron's 3.1. So that's just a simple addition of we expect about 3.85 passengers a day. Over many days, over a year's worth, that would be about our average passengers. Okay, standard deviation though is where it gets tricky. So the standard deviation is not just adding these standard deviations together. It's not that simple. Because if you remember, which probably don't because we did it on calculator, but the formula for standard deviation looks like this. It's like take your number minus the mean, then you square it, and in this case you multiply it by the probability of it, and then you do the sum of all of those, and you do the square root of it all. So what these numbers are, these standard deviations, are just square root numbers. And so, let me think about it this way, like, in math, am I allowed to add the square root of 4 plus the square root of 8 equals the square root of 12, like whatever. We're not allowed to add the square roots together, right? So what we have to do, these standard deviations are square root numbers. So how do I get rid of a square root? To do the standard deviations, you have to do the standard deviation of x squared plus the standard deviation of y squared, and then undo the square by square rooting it. So that's what I would do here. I would square this number, and then add them together and square root it.
So would it just be 4 plus 8 is the square root?
Yeah, so like in this case, it would be...
It's the square root and the square
Yeah.
each other out.
So, what we're going to do is we have to take our square root number, which I think was like 1.09. You have to square it plus 0.94 squared, and then do the square root of that to get your new standard deviation. So I'm adding together, what this is like the spread of Pete plus the spread of Aaron kind of get globbed together into this new spread together. But they're not just straight one-to-one add. They're kind of this weird mixture. So you just do in your calculator square root 1.09 squared 0.94. Let's see. I got 1.44, I think. So do the square root of those. So you can't just simply add standard deviations together. So they're kind of like a weird number. They have that, the formula with them is tricky with it. And so we need to square them first, then add them together, and then do the square root. So that's that one. So on the mean, you just simply add the means together. That's our average, but then here's our new standard deviation. We hope to vary, or we're going to vary somewhere around 1.5 passengers. All right. Let's do a few more examples here. So this one adds an element of something else. So on number 6, I have a auto dealership keeping track of sales and lease agreements. And S is the number of cars sold in a day. And L is the number of cars leased during a day. And here is our numbers. I have a sale and lease number. Alright, part A, which is actually just the question we're doing. The dealership manager receives a $500 bonus for each car sold. So what that means is we get to multiply by 500 for each car sold. So for each car sold, and $300 bonus for each car leased. So times 300 for each car.
Wouldn't it be added? Seems like it's a bonus.
Yeah, but for each one.
Oh.
It's not like for the day. If it said $500 for the day for selling a car, but I don't know how many cars I get, or sold or leased or whatever. Okay, find the mean standard deviation for the total bonus. So I want to combine the total sold and leased things for a day. So what's my expected amount of total money earned? Expected amount of total money earned. So we expect to sell 1.1 cars a day. So this is just like per day. I expect to sell 1.1 cars a day, and I receive $500 for that because it was 500 for each car sold. Then I add the 7.7 cars leased a day, so like over many, many days, not quite having a leased car a day, and I expect to get $300 from those sales. How much money per day do I expect to get? So 1.1 times 500 plus 0.7 times 300. I think something like $760 per day. So that's our expected amount. I expect that's our average, but we know that like this guy's not going to do exactly that every day. There's some sort of varying factor, a standard deviation, and so we want to get like what's our typical distance from the mean? What's our standard deviation? Okay, so I have each of these standard deviations. But we're also gonna, since we're multiplying, this one adds another element of, we're also gonna multiply these, and I have to do what we did here, where it is the standard deviation squared plus this one squared over the square root. So on this one, I have to take the number of cars sold, 0.943, and I get a $500 bonus for that. So I do get to multiply. If it was adding, I wouldn't do anything to the standard deviation, but I do on this one. And then, maybe I'll do it in a different color so we can really see it. I have to square that because it's like a square root kind of number. Then I'm gonna plus 0.64 times 300. And I'm going to square that, add those together, and do the square root of it all. Alright, so the multiplying, just put it into money, like how much money is the standard deviation, and then we had to put them together by squaring them each, adding them together, doing the square root. And we're going to get our typical spread, how much we typically vary. from the mean is something like $509.09. At least that's what I did before. Hopefully it's still right. $509. So that's a pretty big spread. Could get anywhere from $200 on the day to like $1,300. So expected amount, combining these two things together. So combining expected is just take those two expected values and add them together. In this case, we added the whole like dollar bonus thing. And then for spreads, I need to square them, add them together for a spread. Any confusions, questions, worries, doubts before we do our last one? Like, not clicking it. Aaron's like, I got it. Alright. Okay, in the last one, in a certain population, the average male height is 69 inches with a standard deviation of 3. The average female height is 64 inches with a standard deviation of 4. Define the difference in male and female heights as male minus female. What are the mean and standard deviation of the difference in mean and male and female heights? So we're trying to find out what is our like average difference, like how much taller are males than females on a given average there. So like what is my expected amount of event D, which is males minus females. You could also see it written like this, like what is the average amount of D? Or even like this, the average amount of male minus female. Instead of just saying D, it might just say those two events. So what's the expected amount? Well, I typically have a male as 69, a female as 64. So we expect to have males be 5 inches taller than females. We expect a difference of 5 inches. All right, but we know that that's not true for every single male and female that you ever combine together. And so there is a certain spread that we need to account for. So what is the spread, the standard deviation from the mean? So let's see, 3 and 4. And we're talking about a difference here. So the difference, like on the expected number, we subtracted. So would it make sense to do 3 squared minus 4 squared over the square root of a number? Like, because that's what we would do. The mean minus the female square root. Would this make any sense? This doesn't make sense, so don't write this down. Because that would be 9 minus 16, which is like the square root of 7. And that would be like some decimal to the I. Like if y'all did imaginary numbers, and that's a fake number. Like it's not real. You can't do -7. So there's no way we can have a negative standard deviation. Like think about what is standard deviation. It is, here's our average, here's our spread. Here's the female's average, here's their spread. So when I combine the male and female together, the spreads don't magically get smaller. The spreads always get bigger from each other. So actually on here, we're always adding the standard deviation. So like a star, you always add standard deviations together. So like on these two, when you're asking to subtract, you can subtract the means, but you never, ever, ever subtract the standard deviation. So the spread just always increases. You always get a bigger variation between the two. So it wouldn't make sense if our spread got tighter, or we're adding more elements together, it makes our spread bigger. It makes the unknown bigger when we add elements together. So you always, always, always combine. When we're combining, it makes the spreads greater. The unknown is greater. So I think 3 squared plus 4 squared is 25 divided by square root of 25 is 5. So we have a standard deviation of 5 inches. Alright. So I expect that males are 5 inches taller than females, but we can vary anywhere from a typical number, so like an average amount could be anywhere from like 0 to 10 inches taller. So like they could be the same height, they could be a foot taller. We don't know. There. Alright. Which, if you remember, so like a standard deviation, because we know that there's females that are taller than males. So like if we go back to normal distributions, if I have 5 inches, I have like 0, -5, -10, 10, 15, 20. So like there is a population of people where the girls are taller than the boys at the same age level. Like, and we know that. It's just the majority of people, the males are taller. When you just compare a random male and a random female. Alright, so that's actually what we're going to do on B. Assuming that these distributions are normal, what's the probability that a female is taller than a male? So they said assume that these distributions are normal. So what is the probability? What's the probability that a female is taller than a male? That's like saying event D is less than 0, because event D was like males minus females, I think. So like I actually just drew this picture kind of on accident, but I guess I was thinking about it. Like it's this little picture that I drew, and like what's the percent that had this? So on event D we had a mean of 5. Here's the event 0. What's the probability that this is where females are taller, this is where males are taller? So how much percent of our data are females taller? So this is where, yeah, it's like about 60, yeah, so it'd be like you could use the 68, 95, 99.7. How about we use like the exact number on the Z table, which 16 would be a fine answer. Let's just go for, like you could get the Z score, which is your event minus the mean divided by standard deviation. So like your number minus the mean divided by standard deviation. So that would be -5 divided by 5 is you are -1 standard deviations away. So yeah, we did say 68, 95, 99.7, but let's use like the table here and look it up on the formula chart. Like a Z-score of -1.00 is 0.1587. So basically 16%. 0.1587. So like 15.87. 0. So I look up that value in the table, and it says there's about a 15.87% chance of that. Or in other words, 16. which that makes sense. There's plenty of opportunity for females, a random female and a random male, where the female's taller. Alright. So let me see. So go back here. Again, kind of the main thing is like you're never going to subtract spreads. When you're adding elements together, the spread, the unknown, just gets bigger and bigger. It never would get smaller. So this value, that could never get smaller. Another main point is we have to square these standard deviations to add them together. And do that good stuff. Alright. So let's see. So I got a little worksheet here. So it's 1, 2, 3, 4 with some parts to it. So this is the front page. We're going to work on this, and you're going to turn it in, and then we'll be done.
We still have homework.
Oh no. Oh no.